Hello, everyone. Welcome to Mirantis Labs Tech Talks, where we dive into cloud native topics, use cases, tutorials, and many more to educate you all. I'm Avinash Desireddy, Senior Solutions Architect and Developer Advocate here at Mirantis. Joining me today, Roman Kuzmin, a DevOps Engineer here at Mirantis. Roman, thank you so much for joining me here today. Can you tell us a little bit more about yourself and what you do at Mirantis?
Yep. Thank you, Avinash. Thank you, everyone, for coming. So, by the way, I have like the introduction inside my slides. So let me start sharing my screen and we can get started.
Sure. So before that, just like few housekeeping items. There, you can post any questions that you have using the Q&A panel or using the chat window, and we will get through those questions like throughout the sessions. And anything else that you would like to let us know, any connection interruptions or anything else you would like to communicate, please use the chat window to let us know. And with that, like Roman, let's get started.
Yep. Okay, cool. Thank you, Avinash, once again. So before introducing, I want to say what this talk will be about. It will be about like the monitoring and log management in Kubernetes using Prometheus, Grafana, and Loki. So we are going to talk not only about those tools, but also about monitoring in general and like in Kubernetes specifically. And also we'll briefly take a look at some other tools related to this like stack. Yeah, but probably some of you have question in his or her head, like, who are you, dude? What are you doing in Mirantis? So let me quickly introduce myself. My name is Roman Kuzmin. I'm DevOps Engineer at Mirantis. I really like all these like new DevOps related tools, solutions, and approaches. And I'm also one of the main developer of the Lens autopilot solution from Mirantis. So on the slide, you can see my GitHub if you're interested, and also LinkedIn. So here's the agenda for today's talk. First, we will talk about monitoring in general and why you need it. Then we briefly will take a look at the how the Kubernetes control plane performs cluster monitoring and how it uses monitoring of your applications. After that, we will discuss our LMA stack architecture like Prometheus, Grafana, and Grafana Loki. And finally, we will jump into Kubernetes cluster. And I will show you how monitoring works in Kubernetes, how to access logs, etc. And also we'll show you a demo of LMA stack and how it uses all the monitoring related things. If you have any questions during the talk, please feel free to interrupt me and ask them in the chat, or you can just hop into the discussion. So let's start with monitoring. Why do we need it at all? Here are the main points about monitoring importance. So first of all, with monitoring, you know when application is not working as expected. Or for example, underlying infrastructure in general, like nodes, networking, etc. Also with monitoring, you have the ability to debug and gain insights into your applications. Or again, as I said before, like into the whole infrastructure. Yeah, also it's very useful to track changes over the time to make technical or business decisions based on these changes. In other words, like monitoring can provide you with trends of resource utilization, error messages, warnings, etc. Also with monitoring, you know your weaknesses, like weaknesses of your application or infrastructure. And by avoiding or fixing them, you decrease downtime of application to minimum. And all the above lead to saving money for business in general, which I believe is one of the main goals of the business. You for sure want to get money, but at the same time, you want to spend as much, you want to spend as less as possible, right? So Now when we know why we need monitoring and why it is important, we want to actually monitor our application and infrastructure, right? So let's continue our journey. Let's quickly get back to some time ago when Kubernetes was not so popular and most of the workloads and applications were running on VMs or on bare metal. Then most of the applications were using monolithic architecture, and it was pretty easy to monitor because, like, you know, it had just a couple of log files and a couple of processes running. So you will just need one like APM tool or something like that. It was pretty easy to monitor. But as we all know, after monolithic, there was, and it still is, microservices architecture, which became kind of like industry standard, right? And it became really hard to monitor a lot of different services, applications, like collecting logs from all your applications, like all parts of your application, and so on. So the cool thing about Kubernetes is that it creates this monitoring layer for your application. Like on the slide, you can see how it works on a high level of abstraction. So there's a program that collects all of the metrics for cluster components called metric server. So here they are. So metric server discovers all the nodes on the cluster and queries each node's kubelet for CPU and memory usage. So the kubelet acts as a bridge between Kubernetes master and the nodes, managing the pods and containers running on a machine. So the kubelet translates each pod into its containers and fetches individual containers, container usage statistics from the container runtime. All those collected metrics you can see by executing, for example, kubectl top or like kubectl describe nodes commands. I will show them on a real cluster a bit later. But by default, Kubernetes itself cannot provide you with metrics that are, you know, specific to your application. It only shows your RAM utilization, CPU utilization, app time, etc. So in other words, all the metrics that are generic for all workloads. And that's actually where Prometheus step in. So what exactly is it? Prometheus is an open source system monitoring and alerting toolkit. It joined CNCF in 2016. So the Prometheus collects and stores its metrics as a time series data, which means like the metrics information is stored with timestamp at which it was recorded, alongside with optional key value pairs called labels. So the labels is one of the most important thing about Prometheus, and like, you know, this is like the feature that makes Prometheus like very powerful tool. So on the slide, you can see the Prometheus architecture diagram on a like high level of abstraction. So the interesting thing about Prometheus is that it's using the pull model and not the push model. That means that Prometheus collects metrics from services and like not vice versa, not services sending metrics to Prometheus. So you can see it here on the diagram. Like for metrics to get exposed, you need like the exporter. It's like, you know, just a simple program that can expose the metrics in specific format for Prometheus at some endpoint, and Prometheus server just go into that endpoint and pull in all these metrics. So all that means, like the pull model, it means that the only thing you need to do on the application side is to expose metrics on some endpoint, as I mentioned before. And like the rest, like the collecting, processing, storing, etc., all these operations rely on Prometheus. So Prometheus inside using like time series database, like it cool thing to like use time series database for collecting metrics, because like the time series database differs from like typical database in a way that it has, like, you know, the optimization for storing values that are differs from each other, not so much. So yeah, this is the cool thing about like the Prometheus like storing metrics. Also, there is a tool called Push Gateway. You can see it here, which is the part of like Prometheus. It's like, you know, different project, but they also always comes with in a conjunction. This tool is responsible for collecting metrics from short-lived jobs. Like, for example, part of your application or like whole application is just built on jobs, on cron jobs. And the thing is that is like, you know, this part is not living a long life. So it's just do something and then like the control plane kills it after it's done. And like the job needs just to push metrics to push gateway. And Prometheus will pull those metrics from push gateway. So also one of the most important part of Prometheus is alert manager. It's not actually the part of Prometheus, but they like in a case with push gateway, they also come together with Prometheus very often. So this tool is responsible for sending alerts to any channels, like, for example, email, Slack, PagerDuty, etc. And also the cool thing about like all these solutions is that they're open source. So you have like the source code, and also usually for open source solution, the community is really great. So you will always have like a good documentation, and it means that you can easily create, for example, your own integration for alert manager. Like, for example, I don't know, you have some messenger that you use on your work, so and you can see like the integration for this messenger. You can easily create one. It's not like will be, of course, very easy, but it's just doable. You can do it. And also for the visualization, there is Grafana. They always, not always, but very often come together with Prometheus stack. So let me just quickly talk about Prometheus a bit more, and I will come back to Grafana in more details. So as was discussed earlier, Prometheus uses a pull model to collect metrics. So probably you're thinking why it uses pull rather than push. Pulling over HTTP offers a number of advantages. For example, you can start extra monitoring instances as needed. Like, for example, on your laptop when you're developing changes, and you can easily like collect metrics from your developing environment and see it in one just Prometheus instance whenever it you know, lays on any cluster, on any environment. It doesn't matter. You just need to like expose your endpoint and need to specify this endpoint in Prometheus configuration. Also, you can more easily and reliably tell if the target is down. Like that's pretty obvious, I think. And also you can manually go to target and expect its health with a browser. So it's also a cool thing about pull model. So let's talk a bit about metrics types that Prometheus is using. So the Prometheus client libraries offer 4 core metric types. You can see them on a slide, so I will describe all of them. So the first one, called the counter. A counter is a cumulative metric that represents a single monotonically increasing counter whose value can only increase or it be reset to 0 and restored. So as an example, you can use counter to represent the number of requests served, tasks complete, or like errors, for example. It's highly recommended not to use counter to expose a value that can decrease because, you know, it makes no sense, obviously. So for example, do not use counter for number of currently running processes because, like, you know, there could be more of them or less of them in like different time periods. So for scenario when you need to expose like the metric of currently running processes, it's better to use a gauge. It's like the second core type of metrics. A gauge is a metric that represents a single numerical value that can go up or down. So gauges are typically used for measured values. Like, for example, it could be temperature or like current memory usage. But it also counts that can go up and down, like the number of concurrent resources, or as we mentioned before, like the number of currently running processes. So the third one is histogram. Histogram samples observations, usually things like request durations or response sizes, and counts them in configurable buckets. It also provides a sum of like the summary of all observed values. And last but not the least, definitely, is the summary. Similar to histogram, a summary samples observations, like, as I mentioned before, usually things like request durations and response sizes, while it also provides a total count of observations and sum of all observed values. It calculates configurable quantiles over a sliding time window. So it's pretty interesting thing to. It's kind of hard to probably understand, but once you get familiar with it, you will understand why you need to use it. So Prometheus is used not only for collecting metrics and storing them, but also for querying them with a very powerful and flexible query language, which called PromQL. So it has a plenty of functions and operators. So you can create a very complex query. For example, you want to create like really interesting query that you can get like in a simple get request or something like that. So here are some examples of PromQL usage. So for example, to return all time series with the metrics HTTP request total and the given job and handle labels, the PromQL query will look like this. So in curly bracket, you just specify like the name of the job and like the handler. The second example is using regular, like PromQL can use regular expressions. You could select time series only for jobs whose name matched a certain pattern, for example. And in this case, all the jobs that end with server will match like this query. If you have two different metrics with the same dimensional labels, we can apply binary operators to them and elements on both sides with the same labels set will get matched and propagated to the output. So for example, this expression here will return the unused memory in megabytes for every instance on some fictional like cluster. So you can see that you can just use this like 1024 and get like the total amount in megabytes. And the same expression, but summed by application, could be written like this. You just apply a sum function before like the query, and it will just sum all of your like the instance memory limit bytes by application name. So PromQL is important because it's used in both Alert Manager and Grafana. And now when we have metrics collected with Prometheus and we actually can query them, we obviously want to visualize them. So that's where Grafana steps in. So what exactly Grafana is? Grafana is a multi-platform open source analytics and interactive visualization web application. It provides charts, graphs, and also it provides an alert. So it's just a bit different thing from Alert Manager. So for the web and when connected to supported data sources. So these supported data sources are like, for example, Prometheus and Loki. I will show you some other like examples of data sources a bit later. So Grafana allows you to query, visualize, alert on, and understand your metrics, no matter where they are stored. So in Grafana's case, it's better to show one time than say 100 times. So this is a simple example of Grafana dashboard, like for Kubernetes. In my opinion, it looks really impressive because it looks also fancy. You have a lot of different colors and it's very illustrative to to understand your metrics and what is happening in your cluster. So also, as I mentioned before, the cool thing about Grafana is that it supports plenty of data sources. You can see examples of the slide, and it's a really small part of already created integrations. And as I mentioned before, for Alert Manager, here you can create your integrations too, like by yourself. There's a good documentation on how to do this. So each data source has a specific query editor that is customized for the features and capabilities that the particular data source exposes. So the query language and capabilities of each data source are obviously very different too. So you can combine like data from multiple data sources onto a single dashboard, but each panel is tied to a specific data source. So the panel is like the part, like the building part of dashboard. So we will discover some other Grafana visualization and the dashboards later in the demo. So the last piece of LMA for today, but not least, of course, is login. So let's talk a bit about Grafana Loki. So what is it? And to be honest, it's my like favorite tool for login because it just blew my mind how simple yet powerful it is when I first discovered this tool. So Grafana Loki is a set of components that can be composed into a fully featured login stack. Unlike other login systems, Loki is built around the idea of only indexing metadata about your logs, like labels, just like the Prometheus labels. So log data itself is then compressed and stored in chunks in object storage, such as S3 or GCS or like wherever object storage you're using, or even it can be stored locally on a file system. So this is the slogan of Grafana Loki. It sounds like Prometheus, but for logs, and this is exactly what it is. So metadata matching between metrics and logs is critical. The idea of Loki is to run a log collection agent on each node that collect logs using the agent, talk to Kubernetes API to figure out the right metadata for the logs, and send them to a central service which can be used to show the logs collected inside Grafana. So the agent supports the same configurations as Prometheus. Like, for example, you can relabel some of your labels if they're not looking as you want. So to make sure also that metadata matches, this agent is called Prometheus. Here it is on this slide. So Prometheus is very flexible in terms of which logs can be collected by it. You can configure it to collect logs from any file on the node. It's like, very simple. It has very simple configuration. That means that you can easily collect some custom logs from your application, or like you can, with Prometheus, you can use it for collecting any, not even the logs, but any like source of like text files or like wherever. Now let's take a closer look at the architecture components. Here we have distributor, ingester, and query. Once Prometheus collects and sends the logs to the Loki, by the way, this is Prometheus, this purple dot. So once Prometheus collects and sends the logs to Loki, this distributor is the first component to receive them. Now we could be receiving like millions of writes per second, and obviously we wouldn't want to write them to a database as they come in, because that would kill any database out here. So we would just need to batch and compress the data as it comes in. So basically what distributor is doing is just assigning log streams to like different ingesters using some hash algorithms. Then the ingester will receive the entries and start building chunks. This is basically gzipping the logs and just appending them one after each other. So once the chunk fills up, like the ingester flash it to the database. Loki uses separate databases for the chunks and for indexes, as the type of data they store is different. So it's kind of was all about the write path, like this path from Prometheus to distributor to ingester and to database. But what about the read path? So the read path is quite simple and has the queuer doing most of the heavy lifting. So given a time range and label selectors, it looks at the index to figure out which chunks match, and then grabs through them to give you the results. It also talks to the ingesters to get the recent data that has not been flashed yet, that like is just stored locally on ingester, like in memory or something like that. So that's what's pretty much it regarding theoretical path part. So now let's do some stuff by ourselves. So let me jump into the so for the demo I will use Lens. And I already have a cluster with pre-deployed Prometheus, Grafana, and Loki, like the tools that we discussed in our talk. And also there I have a bunch of the workloads for like different tools, etc. So we can see it like will act as a real cluster, but with very little workloads. So first of all, let me just show you how you can get info about resources, CPU utilization, like memory utilization, etc., just with kubectl. To do this, you need to like get nodes, get the list of the nodes.
Roman, if I may interrupt, can you like zoom in a little bit on the window? I think the font size is too small.
Yeah, for sure. Is it better now?
Just a little more, please. Yeah, I think it looks better. Thank you.
Okay, cool. So this is the list of the nodes that the cluster consists of. So for example, let's get this node and we will do kubectl describe node command and put the name of the node. The Kubernetes control plane will provide us with the like full information about this node. It will show you the info about CPU requests, limits, memory requests, memory limits for every pod. So it's easy to understand how much allocatable CPU you have, ephemeral storage, memory, how many pods you can execute on your node. and also like the full capacity of this node. So you can do you can describe any node that you want and get the understanding what is happening in your cluster. Also, there is another command called top. So it's like, I think this is like something like an analog for Linux top command. So let me show you top node and the name of the node. So this is just the summary of how many CPU cores is used, like the percentage, like the memory in bytes and percentage of memory. So you can get it. So it's just like the summary of this information. So also you can do kubectl top for any pod that is running on your cluster. So let's, for example, take like any pod like this for Argo CD, for example, and we will just describe how many resources it uses. Top pod name, and also we need to specify the namespace. So we can see that it uses like 1 M CPUs and 28 megabytes of memory. So also you can get like the CPU requests and limits for the pod. To do this, you need to execute kube describe pod and the name of the pod, and also specify like the namespace. You also will get a lot of different information that might be useful for you. But here, what I can show you, what I want to show you is the request and limits. Okay, so for this pod, we don't have limits and requests, but it's kind of, you know, out of scope of this talk. But anyway, like if you don't have any limits or requests, it will just, you know, will be best effort quality of service class, which means that Kubernetes itself will manage like the limits and requests of this pod by itself. Also, another command to that might be useful for monitoring purposes is kubectl log command, and you need to also specify the name of the pod and the namespace. Yeah, logs, sorry. So yeah, you can see the logs of this particular pod. So to make it possible for Kubernetes to collect the logs of your application running in the pod, you need to write all your logs to the std_r or std_out. So the Kubernetes in this case will do all the heavy lifting and collecting logs for you, and you can see them with executing kubectl logs command. But with Lens, you can just you know, click on some buttons here and there. Like for example, here you have this button to get logs for your files, for your pods. Sorry. Yeah, and also the thing is that the Lens is just get all this information from kubectl control plane and just visualize it. So probably we can discuss like the Lens monitoring features in the future talks. So also let me show an example of the exporter. It's just, you know, just some application that take the information from another application and like the expose metrics via some endpoint. So for example, I deployed here kubestat matrix pod, and it has this endpoint like HTTP 8080. So I will just do this thing. Will just do the kubectl proxy command, Zoom a bit. So you can click on metrics, and this is like all the metrics that this exporter actually exposed. So these metrics, like you see, there's some headers, some comments, and the metrics itself are in the specific format. So this format consumed by Prometheus, and you can query those metrics, this information inside the Prometheus. So let me then jump into actually Prometheus and show you how to do this. So, for example, these all the like the metrics that we seen before in the at the 8080 endpoint of the kube state matrix pod. So, for example, let's get like the config map info. Oh, I think I need to. Yep, I need to do kubectl proxy once again. Here we go. Yep, config map info, for example. So you can see there the information about config maps. And also while you querying, you can see what type of metrics is it. It's gauge. You can see here like the name of the config map, like the instance that collected this metric, the namespace, like the pod, and etc. So this just like, you know, summary of the names of the config maps. Like, for example, you can get some of the config map info, and this is like the exact number how many config maps are on your cluster. Another example, so of the metric is qpod info, for example. It's gauge again. So this is this metrics has different labels, like, for example, created by kind, created by name. So for example, here you see that this pod was created by daemon set, also like the host IP, and like some different information about pod. So for example, you want to understand how many pods in each namespace is running. You can do sum by namespace. This is name of the label, and we need to put this in brackets too. And so here you can see that, for example, in namespace kube system, you have 52 pods running. In Stacklight namespace, you have 51, and so on. So another example of query is, let me copy and paste it. So for example, you want to understand resource, like the CPU limits, CPU requests, sorry, for a pod that has label minio. This label app equals minio. I can show you that we have those pods here. Here they are, and also it has labels app equals minio. So this query will get you an info for every pod that has label app equals minio, and we'll get the information about CPU requests. So let's execute it. So you see that every pod, we can see there in minio, for minio deployment, has like 0.025 CPU requests. So probably it will be helpful in some cases. Also, you can sum this query and get like the total amount of CPU requests by minio deployment. So yeah, Another example of the query for Prometheus. Let me again copy and paste. So this query will find the number of containers without CPU limits in each namespace. So as you can see here, for example, in StackLite namespace, we have 23 containers that does not have CPU limits set. And it's a best practice by like Kubernetes to have CPU limits and CPU requests. So this might be helpful too. So let's then jump onto Grafana dashboard, like the Grafana web UI. I'm just wondering if it works. Now I need to do kubectl proxy once again. So this is like the homepage of the Grafana web UI. So let me show you the data sources that I have here. So there are two data sources, like the Prometheus and the Loki. This is just like, the URL of service inside the Kubernetes. So if you have your, for example, Loki instance in the same namespace with Grafana, you don't need to specify namespace. But here, for example, you can specify two and even the port, and like, you can, it could be like running on another cluster. For example, you can use the one Prometheus instance for like different clusters, and same with the Loki. So also, let me quickly show the pre-installed dashboards. So I just installed it, like deployed the Grafana with the Helm chart provided by community. You can find this in the GitHub page for Prometheus stack. So it already has plenty of dashboards. So for example, this one that I showed you before in the slides. So you have all this info here. You can like interactively use it. So to find like at the same at like particular timestamp what exactly was happening. And also cool thing about Grafana is that there are plenty of dashboards created by community. So you can find it at the grafana.com/grafana/dashboards. So this is all like the dashboards for Grafana. So it has like for HTTL, for RabbitMQ, for Nginx, etc. So you can even create your own one, like the dashboard, and put it here too, and any user can use it. So I want to show you how easily you can install this dashboard into your Grafana. So for example, this dashboard for like storage for volumes in cluster. So to install it, you need just to copy the ID of the dashboard, then open your Grafana web UI, go to browse, click on import, and here you need just to specify the ID of this dashboard, like that we faced here, and click on load. Select their Prometheus data source and click import. And it will import the dashboard, so you can like start to use it just immediately. You see there's like a lot of different information already collected, because like it is stored in the Prometheus. So another example of the dashboard is like for API server. So also you can do this in two ways, or for example, you can either copy the ID or download the JSON. So in browse, once again, in the import, you can just copy and paste JSON file here and click load, but we won't do this. We just copy the ID and put it here again. Click on import, and we can immediately use this dashboard. So we can like obtain info about API service request rate, like work queue, service time, etc. Like also you can create your own dashboard. So I will show you an example here, for example. So you need to click on add panel and add new panel. And here you can just specify the query for the Prometheus and it will show the data. So let's, for example, use the query that we used before. Yep, here it is. So it's not like a good thing to use time series, I think, for such information. So we can change it, for example, for a bar chart. Oh no, this is bad too. Yeah, better to use gauge, I think. So you can see like for every namespace amount of pods running. Yeah, but you can definitely save it, describe your changes here, apply, and you can see it here. You can move it or like whatever type of the like interaction you want to do. You can expand it a bit or like, you know, whatever you want to do. I want to show you also how to use Grafana. Yeah, let's save this dashboard. I want to show you how to use Grafana Loki. So you can browse it, like you can query your logs from Grafana because we already added Loki as data source. So for example, you want to like for pod with the name Argo CD, you want to see the logs. And here they are. So this is logs for this Argo CD pod. You also have some labels, for example, here of the log. So also detected fields you have here. And the cool thing is that for Prometheus, you can write your like, you know, some type of query or like regular expressions that can parse your like string of the log and get it here. So you can use it as labels for Prometheus. Yeah, but also we have a dashboard for Loki. So yes, see you here can just specify the application in the namespace, like for example, I don't know, Calicon node, or yeah, let me show you. I know that I have some problems in this starboard operator application, and you can like enter your string here. For example, I want to see all the error logs, and it filters for you, so you can expose it and like see the exact trace, like for what logs contains inside it. So yep. Yeah, I think that's pretty much it about all the monitoring and log solutions. So thank you. If you have any questions, please feel free to ask them.
No questions so far. Thank you so much, Roman, for extensive details. They are very helpful. In the meantime, just a quick reminder, if you do have any questions, feel free to use the Q&A section or the chat window to post them, and we are happy to take them. Okay, in the meantime, okay, there's one question. I can read it out. What if we can log from other locations from different servers?
Yeah, for sure. So you can, in the configuration of Prometheus, it's like the agent. Let me show you. So this is the agent of the Loki. So you can put Prometheus application on your node or like server or wherever you want it to be at, and specify like the configuration for Loki and Prometheus, and say them how to interact with each other. So it's pretty easy to do.
Okay, hope that helps, Okay, with that, we can go to the next slide.
Yep.
Yes. Quick note, Mirantis is hiring. If you'd like to join Team Mirantis, feel free to check out the open positions at mirantis.com/careers, and then our team is happy to consider your application and then find a suitable role accordingly. With that, we can go to the next slide. We have a few upcoming tech talks in November. One is on improving application stability with Kubernetes health checks, where we'll be talking about like different health check probes, etc., to improve your application stability. And then on November 22nd, there's the talk on gRPC and then Kubernetes and what is the gRPC support on Kubernetes. So we'll go through all the details on this. Feel free to check out the labs.mirantis.com and sign up for the upcoming sessions. And there is one, before we wrap up, there's one more question in the chat.
Yep, I see.
Yep, sure. Roman, please go through that.
Yep, let me try to answer this. So the thing is that metrics, so for metrics, you're create an exporter which exposes those metrics in a specific format for Prometheus. So Prometheus can easily consume those metrics. And in case with logs, you often don't want to process your logs in like any type, like you don't want to create any additional layer of processing your logs. So in such case, like the logs is just the strings, and you can with Loki you can get those strings like from any file, which means that you don't need to create like exporter in case with Prometheus or any other additional layer to parse your logs, like the Prometheus and the Loki will do it for you. I hope this answered your question.
Okay, hope that helps. All right, thank you. So with that, we can wrap up the session. I hope you all enjoyed learning about like Prometheus, Loki, and Grafana. And what happens like as next step is like you will be receiving an email with the link to recording, slides, and then the upcoming sessions information. Feel free to sign up for the upcoming sessions, and we hope to see you on the upcoming sessions. And thank you so much, Roman, for joining me today. It was great to have you here. And thank you everyone for your time, and hope the session is valuable to us. Feel free to share your feedback from the email that you receive, and we'll be happy to consider them and then incorporate in our upcoming sessions. And also, if you have any recommendations for any topics that you are interested in learning, feel free to send us a quick note, and then we'll be happy to incorporate them as well. With all this information, thank you so much, every one of you, for joining us today, and we hope to see you in the future sessions.
Yep, thank you
so much.